Hey guys, how's it going? We're finishing up our day two of radicals and radical functions, and I've kind of, I've kind of already gone ahead and kind of done a few things, and we're going to talk about it, and hopefully I can make some sense to this, out of it for you. I accidentally forgot to hit the record button on the voice, so I kind of yeah. Okay. Well, with that being said, we're gonna talk about the cube root. We're gonna find some cube roots today, and hopefully you've already looked at the video concerning graphing cube root functions. And for some reason, I wrote cubed. I shouldn't have put the D. I don't know why I do things like that sometimes. Anyway, those are the main things that we're going to talk about for radicals and radical functions. Then we're going to go on to rational exponents, and we're going to finish off with the objectives here. Understand the meaning of a to the power of 1 over n, understand the meaning of a to the power of m over n, understand the meaning of a to the negative m over n, and I'm going to leave that as a question mark here, and I was actually going to remind you about what it meant, but I do that later, and I wanted you to figure it out, but unfortunately, blah, whatever. But you'll see what that means again. If you don't remember right off the top of your head, if I said something like, 3/4 all to the negative 2, then that implies that it's what? It's 4/3 all to the square. Okay, you're just flipping the or taking the reciprocal of the inside. That's what this means. The negative, it means inverse. Okay. So we're going to use the rules of exponents to simplify some expressions that contain rational exponents, and use rational exponents to simplify radical expressions. And the way that I do things, I'm hoping that you'll like them. I tend to not use the radicals as much, and you'll see why, I hope. So we're going to take a few problems here, and the very first one I did out was what was it? Which one was it? No, I'm lost. Oh, there it is. It was number 3A. Find each cube root, assume that all variables represent positive numbers, and that's important. So what I did was I reminded you about the index number. That index number is 3, and we have a power on 8 that's really 1, and that's why I rewrote the 8 to the 1/3 power. So just as a remember, any base raised to the 1/3 power is the cubed root of that base. Okay? Hoping that you're starting to see the pattern. If I take the 4th root, then that's the 4th root. You see, it starts to build up a pattern here. And what you can see is I build up 1, 2, and 3 2's because that's what it tells me that I need. I need 3 of things to pull 1 out. And that's what I did. I pulled 1, 2 out, so the cubed root of 8 is 2. Then I did another problem. From 3, I believe it was B, so I did the cubed root of 1 over 64. I think I did all of them, actually, so we can just probably go in order. And I kind of drew this one out a little bit, but I'm not so sure if it's understandable the way that I did it here, so let's talk it through. So immediately I did what? I changed the radical into something with a rational root. And the reason I do that is because it keeps reminding me of what I really need and what I'm looking for, okay? So what did I do? I multiplied 3 1's together. Why? Because 1 times itself as many times as you want is 1. So I just picked 3 of them. And 64 factored out is 4 times 4 times 4, right? Because 16 times 4 is really 4 times 10, 40, and 4 times 6 is 24, so 40 and 24 is 64. So because I have 3 1's And because I have 3 4s, I can pull 1 out, and the answer is 1/4. And you can check it the way I did down here. You can see that all I did was multiply 3/4 together, and when you do get 1/64, which is, remember what this is called? This is called the radicand. Okay? The radicand. Whoops. This is the radicand. No, it's the radicand. Yeah. Oh, tired. Okay. So, here we go. Let's keep going on this, actually. So here's C and D. I actually did both of them out. You can take a look at D, but, you're going to be like, ah. So I'm taking the cubed root of x to the 6th power. So immediately I rewrite the cubed root as an exponential, or a rational exponential here as 1/3. So using the exponential rules and reminding you about them down here, says that we can take any exponent that's raised to an exponent, so a power to a power. Remember, that was the power to power rule. And that power to power rule says we can multiply them together. So when I take 1/3 of 6, I get 2. So when we multiply them together, we get x squared, and that is the cubed root of x to the 6th power. On 1D, we have a cubed root of negative 64x to the 9th, y to the 12th. So you can see immediately again, I know, I'm a stickler for this, if you haven't noticed, but if you like doing it a different way, that's fine too. One of the things that I'm just suggesting is get in the habit of using the fractions, because the upper level courses, we're going to be using them more and more. So what did I do? After I broke it in to, from the radical to the rational exponent. Well, I then did what? Reminded you about the product rule here that we have, which is down here, which I'm making a big arrow at and a big mess, and then I'll make a little happy face. But if I have a product of two things, so A times B, and it's all raised to the nth power, then all I can do is know that it's A to that power times B to that power. And you can keep going on and on and on forever n times, but the product is going to be the same. It's always going to be AB n number of times. So I broke it down like this. I said the negative 64, I raised it to the 1/3 power. I took the x to the 9th, I raised it also to the 1/3 power. I took y to the 12th and raised it to the 1/3 power. Just like we would do over here. If you think about it, you might want to think distribution, but remember, it's really not. But if it helps you remember it, then use it. And then remember what we said here was that we need 3 things to pull 1 out. So, well, we already knew that 64 was a cube and it was 4 cubed. So we just have to add the negative, right? Very easy to get negative 64 because it has to be an odd number, right? An odd number of negatives will give you a negative when you multiply through multiplication. Then I just reminded you that I'm just multiplying these two together. So 1/3 of 9, or 9/3. And then I said 12/3, or 12/3, or 1/3 of 12. So when you break it down, you can see what we get. We get the negative 4, we get x cubed, and we get y to the 4th, because 12 divided by 3 is 4, and 9 divided by 3 is 3. Okay, let's move on. So now we're on a separate section here, and we're finally on the rational exponents part. And let me just make another note here to remind you of this aspect here. So what it's saying is any base raised to the 1 over n power is the nth root of that base. So remember what that was what we were talking about before. If I take like the 5th root of some number, I'm really taking that number to the 1/5 power. And then, if you look at objective 2, understand the meaning of a to the power of m over n. I rewrote it so you could see it in radical form. Notice the denominator is the index number, and m, the numerator, is actually the exponent on the base. So this comes into focus, I hope, a little bit more, and you'll see it through some of the examples in a moment. And the very first example we're going to do is that one right there. And I'm going to make a small note about something that I'm a little stickler about with this one, at least. I really, really want to impress and remind you that the square root, because that's what that's saying square root, the square root of 25 is not just 5. It's not just 5, because we also have -5. So remember, when we're talking about taking the square root of some base that's being squared, in other words, the index number and the exponent on the base are exactly the same. In this case, they're 2, right? And it doesn't always happen when they're exactly the same, but it does happen when they're always the index 2. You're going to get the absolute value of that number that is the base. Well, what does that mean? That means that there are 2 answers. There are technically -5 and 5. All right? Because -5 times -5 is a positive 25, and 5 times 5 is also 25. So be careful about remembering your rules, okay? That's essential, and we'll need to work that out. Now, let's go up to, what was it, 1E, I believe I did. No, I did 1C up here real quick. And remember, 1 says, use radical notation to rewrite each expression. Simplify if possible. If you notice, I'm not following the directions exactly. It says use radical notation. Well, it's good, but you'll see, I'm hoping that you'll agree with me later. But we can have a great discussion about it. In fact, the very first time I recorded this, or the second time, I actually asked a really great question about it, but it's kind of a moot subject now. But anyway, if I look at C here for a second, and I take the square root, or 1 over 49, so that's really saying this, right? The square root of 1 over 49. Well, the square root of 1 is 1, and the square root of 49 is 7. But remember, there are 2 answers with that case, okay? And if I'm not mistaken, the next problem I did was 1E. Yep. So 1E down here says that we're taking the square root of 16x to the 6th power. So you'll notice I sort of did that little distribution trick, and you can't see my fingers, but I'm actually doing the little bunny ears, the little quotes, but, whatever. So we know that if we're going to have some even piece, we're really going to have an absolute value. And that's why I always try to remind people, just put it in before you know it. Realize when you're dealing with a square root, generally you're going to have the plus or minus. There's only a few cases where you're not. So I did the distribution aspect, and I said, well, 16 to the half power, well, that's 4, right? Because there are 2 4s, right? And I need 1, so that's why I get 1 4. And then, if I take 1/2 of 6, if you see it, I'm taking 1/2 of 6, so 6 divided by 2 is 1/2 of 6, and that's 3. So that, plus or minus 4x cubed, is equal to the quantity 16x to the 6th to the half power. Or, I could say equal to the square root of 16x to the 6th. You see? I'm not sure how you want to proceed with doing these kinds of things, because if I wrote it the other way, it's the square root of 16. That's easy, right? But then the square root of x to the 6th. Now, some people might get lost here. Like, oh, I don't know. What do I do? What do I do? Well, they might forget that this is really just x to the third times x to the third, right? That's the exponential way of looking at things through the exponential rules. But we have to remember that we are actually taking two of them, and the index is 2. So absolute value. But it all depends on how you want to look through the problems themselves. All right. Da, 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 da. Which one did we do next? Okay. We did this beastie here. So we're going to use radical notation to write the following, then simplify again if possible. Okay. Again, it's me. Ha, 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 ha. So, I've got my little way to do it. And to remind you again about raising a power to a power, this is the power to power rule, or the PP rule if you want, is a to the mn. Now, notice you're just multiplying the two exponents together. This goes back a ways. So all I did was I kept it in the same notation, and I factored out 81. And I'm looking for what? 4 things, right? So I need 4 of the identical thing to pull something out. So you'll notice how I rewrote this. I did factor out the 2 9s, and then I rewrote it in an interesting way. You might say, well, what happened? Well, keep in mind that if you multiply 3 times 1/4, you're going to be following this rule, and you're still going to end up getting that fraction, 3/4, right? Because 3 times 1/4 is 3/4. So I need 1, 2, 3, 4 3s to pull 1 out, and oh, that was cool. That happened last time, too. That was neat, wasn't it? Oop. Okay. So I took 4 of those 3s, and I can only take 1 of them out. But do not forget about the cube that we're doing here. We're raising it to the 3rd power. We're doing it in the 3rd dimension. So 3 cubed is 27, and that ends that problem. Like I said, if you have any questions about this, please make sure to address them in the stream. It's easier to do that. So let's move on. And then I believe I did B as well. And I did. And notice, like I said, here's the power. And remember, that's the numerator. Okay? The denominator is always going to be the index number. So notice how I rewrote the actual problem. I separated the 1/3 and the square. Why? Because I know that when I multiply them together, I get 2/3. But what does the 1/3 remind me? It reminds me, or hopefully it reminds you, that we need 3 things to pull 1 out. So then I factored it. There's 1 -2, 2 -2s, 3 -2s. So I can pull out of all those 1 -2. And don't forget about the square. So -2 squared is 4, right? Because that means -2 times -2. Oh, I even did this one too. Whoa, we're on a roll now, guys. All right, so 2c. All right, here we go. 2c, this is 2c. 2c, or not 2c. That is not the visual question. That was a horrible joke. I don't even know. But you can see that I went directly to the rational exponents, and I broke it up accordingly. I said what we have, 32x to the 5th, 32x to the 5th, all raised to the 1/5 power, right? Because I can separate 2/5, right, by saying 2 times 1/5. So there's my square, and I can still follow the rules that we were stating out here. So Let's use blue. So then what did I do? I just basically factored out the 32, right? Nothing big. And then I factored out both the 8 and the 4. And I really went the extra mile this time to show you guys a few things, right? How many x's are we multiplying together? 1, 2, 3, 4, 5. So we're multiplying 5, and it says we need 5. Just like we have 5 2's. 1, 2, 3, 4, 5. So that means we can pull 1 2 out and 1 x out. But don't forget about the square. So when we put it all together, we get 2 squared times x squared, or 4x squared. So originally, if you notice this, correct the mistake, I actually wrote down that this was 5, that the x was 5 at first because I was counting the numbers, and it was really quite funny. But I guess that's just me. So yeah. And then we were going to move on to 3b, okay? And 3b goes on to say, simplify if possible, write final answers with all positive exponents. So I took out and I did 3b, okay? And just to give you an idea of that we're doing things correctly, I've left all of the answer keys here so you can see. And you'll note that I was kind of pesky about that one, just me being me. Okay, anyway. So let's walk you through this problem. And then we'll start doing some more, okay? So just as a reminder that the negative exponent flips what's inside, right, of the parentheses, or takes the reciprocal. So you'll notice that I took the 5/3 and I just did what? Took its reciprocal and then lost the negative on the exponent, because remember that the negative exponent really implies inverse, okay? So we're just taking the reciprocal. So you'll see how I broke it down. The very first thing I did was get rid. So I got rid of negative exponent. We don't like them. And what did I do? I took the reciprocal. Okay? Then we already knew what the factors of 64 were. We've factored 64 a couple times. So it was 4 times 4 times 4, but to get negative 64, we have to have an odd number of negatives. Luckily, it's 3, so we're still good. So you can see that I have the 1, 2, and 3 negative 4s being multiplied together, and that will give you the negative 64. I rewrote it here just to show you that I can take 1 over the quantity of negative 4 cubed, and I'm doing it to the 4/3 power. I then did what? I broke it down, right? Well, what's the cubed root of 1? So I'm taking this, right? But we can remember that I can multiply this by 3, right? So technically I can pull one of them out, and that's what we did. And then because it's 3, right, I know that there's 3, so I can pull one of those negative 4s out. And then when you actually, you can take 1 to the 4th, that's 1. And then negative 4 to the 4th power is 256. And that's where I got that number right there. All right, guys, how you holding up? Any questions? If so, make sure at this point, I'll stop for just a couple seconds here and let you guys ask a question in the stream. So while you're doing that, I'm just going to go up and see which other problem I want to do. Okay. Let's do C. Maybe you already beat me to it. La 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 la. Okay, so what does this really mean? Well, it's saying x 1 over x to the negative 2/3. Well, let's not be too crazy about this. Remember, what's in the denominator will oh, that is really neat. Okay, new function I just found out about. Okay, oh, that's really cool. So that denominator will shift right up to the numerator, right? And this will shift right down, right? No. Why? Because there's no negative exponent. There's nothing there. No, there's none. So that still stays. So this is 1 times x to the 2/3 or x to the 2/3. You guys okay? All right, let's see. We got a lot, still more to do. I want to get through a few more things here. So we also did this one. You know what? I'm going to have you guys do this one on your own and see what happens. Don't worry. Just do your best, you know? I'll actually leave it blank down here in the notes section for you guys to work on, and then we can talk about it during the class. That might be an interesting idea. We can try it. Maybe give you this much space. Is this good? I hope. So why don't you try this? Why don't you try it? All right, see what you get. Just remember, let me just give you a hint real quick, because I know someone's going to do this. Remember, the negative 5/9 is only attached to the x, the base, not the 4. So that's my little hint to you, okay? So you try that one out. And let's do some basic ones first. So number 4, use properties of exponents to simplify. Write results with all positive exponents. And this is kind of like a fun little game. You can do this a lot of different ways and have fun with it. But basically remember the fundamental rules of exponents and working with them are always correct. So, law. Oh, okay. I slipped by. There we go. So let's paste this. We'll stretch that out a little bit. Now, just as a reminder, if I take any base to the, let's say, n power, and I'm multiplying any base to the nth power, do you guys remember what the rule was? Well, you take that base and you add the 2. Right? So like, if I said like 5 squared times like 5 cubed, the first, let me do it in different colors. Let me do this one like that. So 5 times 5, and let's do this one in red, times 5 times 5 times 5. How many 5s do you have? 1, 2, 3, 4, 5. So the answer is 5 to the 5th. You see, we just add those two together. So in this case, should be quite simple, especially because we know that the denominators are exactly the same, which is really nice, right? So this is really x to the 4/3 plus 5/3. And that, well, because they have the same denominator, we just add the numerators across. So this is x to the 9/3. Well, that can be simplified, right? Because 3 goes into 9. So what's 9 divided by 3? And that is what x to the 4th, or sorry, x to the 4/3 times x to the 5/3 should equal. So it's all based on the rules we learned previously a while back, okay? So hopefully it'll all start coming back to you, okay? All right. Let's see here. Which one do you guys want to do? Can you tell me? Right now? Huh? Can you? Can you? Can you? Well, we already did a product, so we're not going to do that again. how about we, well, we will do another product, but how about we do something a little different? Maybe C? Is that the one you were thinking? Maybe? Maybe? Okay, let's see. Oops. I was hoping that's maybe the one you were thinking. I'm not sure. But we'll see. We'll see. Paste image. Move it because we don't want it there. And put it down there. Okay. So one of the very first things I would advise is making, common denominators, right? So let's just bring this out a little bit. I'm just going to take the numerator. I'm going to say num. I'm going to say x, and I'm not even going to look at the variable. Let's just not even look at it. Evil, no. Okay, sorry. So we'll just look at the fraction 3/5, right? And we need to have the same denominator as the denominator here of 1/10, right? So this one's kind of easy, right? Because this is 2 times 5, so they both have a 5. One's only missing a 2, so I simply have to multiply this guy by 2 over 2. So I get 6/10, and then I still have the 1/10. And now they have the same denominators, the same darn thing, right? And then we can work it out really easy. Now, remember, multiplication, when you're taking the product of the same bases, you add them, add the exponents. So when you divide the same bases, what do you think you're going to do with their exponents? Yeah, that's right, you're going to subtract them. So I'm going to rewrite this now as x to what power? The 6/10, right? All over x to the 1/10, which simplifies down to x to the 6/10 minus 1/10. And that tells us what? The denominators are the same. So what's 6 minus 1? That's 5 to the 10th, which then equals x to the 1/2. And that is what equals x to the 3/5 divided by x to the 1/10. All right. A few more, and then we're going to have to stop. But I'm hoping this is helping. Please let me know. And then let's do one that's sort of bad, so that way we can just move on a little bit here. Okay, we can do one of those too real quick. I don't think you'll have any problem with the other ones. But let's do 4e. How about that? If we do 4e, that could be interesting. So let's do that, 4e. 4e! Okay. Not 4p! Okay, whatever. Okay. Sorry. Okay. So very first thing, rewrite everything with positive exponents. So the only thing here with a negative exponent is this a, and it's a to the negative 1/2 power. So that guy is going to shift down there, right? We're just taking the reciprocal. So this is really a to the 3/4 divided by a to the 1/2 times a to the 4/3. So we just have to find a common denominator between a half and 4/3, right? So 2 and 3, that's going to be 6. So then what would we have? Well, maybe I should draw it out slowly. I'm not sure. Maybe I'll do it down here. 1/2, right, and 4/3. We need the same denominator, the same denom. So this one we'd have to multiply by what? 3 over 3, and this one we'd have to multiply by 2 over 2, and that would give us the actual same denominator, right? LCD, right? Right. Okay. So let's rewrite this as a to the 3/4 all over this pile of junk, right? It's going to be a to the 3/6 times a to the what? 8/6. And now that we have those, we can add them together, right? So this is a to the 3/4 all over a. Well, 3/6 and 8/6 give you 11/6. Okay, now we get this horrible thing, right? Because it looks horrible. So let's move it down here so I can give you guys more space and myself more space. So now all we need to do is get the LCD for 4 and 6, right? Well, that's pretty easy. It's 12, right? Because 4 is 2 times 2, and this is 2 times 3. And if you just think about it very basically, there's 2 2's with the 4, so this 6 is missing 1 2. And then this 4 is only missing 1 3. The LCD is 12, right? So now, what do? We just make the correct fractions. So now it's going to be what? Well, I have to take 3/4. Maybe I should make that bigger. It's a little tiny there. Okay. So let's just take it over here. How about this? So I have to take the exponent, which is the rational exponent 3/4, right? And I've got to turn it into a denominator, 12. So that's just 3 over 3, right? And that would tell us 9 over 12. Perfect. Now let's do the other one in black. That's 11/6, right? That comes from up here, right? I'm just making a separator. So 11/6, we're going to have to multiply top and bottom by what? 2 and 2, right? Because 6 times 2 is 12, so that gives us 22/12. Yes, okay? So now let's rewrite it. So now what we have is a no longer to the 3/4. We have it to what? The 9/12. So 9/12 all divided by a to the what? 22 what? 12ths. So that tells us that we can use the quotient rule that we have for exponents. That tells us that it's the same base of 9/12 minus 22/12, and that should give you a to the negative, what, 13/12, and that is what's equal to this pile of junk, a to the 3/4 times a to the negative 1/2 all over a to the 4/3. And there's actually a funnier way to do this, but I won't confuse you right now. Okay. How's everybody holding up? Everybody okay? I'm going to be calling the video pretty soon, okay, because I know that it's taking a long time. But I want to make sure you're okay with doing some of these nastier problems as well. Okay. You want me to do one more out of these? Or do I move on? Move on? No, okay, I'll do one more. I'll do G. Okay? But that's it. And then I'm going to only do one of number 5, maybe, or 2. Something like that, I think. And I'll let you explore it on my math lab, maybe. Ooh. Okay. So let's go down. Wow, this just keeps going, doesn't it? Okay. Paste image. Stretch it out. Move it down. There we go. Okay. Well, okay. This one looks pretty bad, but, everything looks bad at first. Don't worry. All we're going to do is we're going to take that exponent and we're going to sort of remember, distribute, but it's not really distributing. So it's 3 to the 4th times x to the 4/5 all over x to the 3/10. Okay, well, I'm not actually sure. Did they want us to keep it as 3 to the 4th? Well, we'll see. You can see what we have here are the two fractions to work with: 4/5 and 3/10. And we need to have the same denominator. Well, this one's not too bad because if we just multiply this by 2, or 2 over 2, we get 8/10, and then we have the same denominator. Okay? So let's rewrite that now as 3 to the 4th times x to the 8/10 all over x to the 3/10. So I'm not going to worry about the 3 to the 4th right this second. However, I am going to take note of the same bases, x, and the same denominators on their exponents. So I'm going to say 3 to the 4th times x to the 8/10 minus what? 3/10. Remember, it's always top minus bottom, right? So that's going to give us 3 to the 4th times what? X, well, they're the same denominator, so 8 minus 3 is 5. So it looks like what we have is 3 to the 4th x to the half. Now, I'm not so sure they want you to keep it as 3 to the 4th. However, this is a good answer. But if you do have to multiply them out, you know 3 cubed is 27, right? So 3 cubed is equal to 27. So 3 to the 4th is just equal to 27 times 3. So that would be 3 times 27, or 60, 81, right? So it looks like it's 81x to the half. I'm not sure which answer they prefer. They did say to leave it all in positive exponents, so technically I answered both of them, right? But, you know, we can kind of take a look in the answer key, what they have up there, just to see. How about that? You can check it out. Let me know if I'm right. Okay. Let's move on. Okay, number 5. Use rational exponents to simplify. Assume the variables represent positive numbers. Okay. Wow. That's a pain, right? Use rational exponents to simplify. Assume all of them. Oh, wow. We're suffering here. We're having a really bad time. Oh. So much work. I know. Oh, I forgot to do this. That's okay. I can do this first. Yeah, that's kind of big. There we go. Okay. Let's make our little line so we can separate things. Okay, so what is this? Well, this is 25 to the 4th power. Do they want us to simplify it anymore? I mean, if you really want to get technical, I guess you could say 25 to the half, all to the half, and then you know that that's that, so you could get 5 to the half, right? You see it? 5 times 5 to the half, all raised to the half, or the square root of 5. I'm not sure if they like that or not. Let me know if you guys like it that way. I think it's funny. But okay. I hope you're laughing. It's not as bad as it looks, right? And again, tell me if I'm right or wrong. It'll be fun. Oh, you want to see if I'm right or wrong? Whoop. Hey, got it. Looky. Okay, we've got to finish this, so I'm just gonna do one from the E, F, G, H, and I'm not sure which one I should take. To be honest with you, there's 3 products and only 1 quotient. You know what the quotient rule is. You take the top and you exponent and you minus the bottom exponent if the bases are the same, and you know the same thing for the radical exponents. But, sorry, my voice is getting a little dry here. Hoarse. We'll take G. How about that? And then we'll end it. And hopefully you can answer that question that I posed to you earlier. Okay, this is why I said writing it out in exponentials are so much better. 1 to the 12th, this would be what? X, what to the 2/3, right? Remember, this is m and this is n, from the a to the m over n. Okay, just as a little sideline. So now we have this product. Well, that's easy. That's x to the 1/12, right? Times x to the what 12th? Because we need to make this a 12, right? We have to multiply by 4, so that's 8/12. So it looks like we have x to the 9/12, or if we reduce it, we have a factor of 3 in both, so this would be x to the 3/4. That's a 4. All right, guys. Man, I really hope this video helped. Let's, why not? Let's just check. Da 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 da. G G G G G G G G G. X to the, oh, they want it in that form. Well, let's see. Did I get it right? Let's see. Maybe I got it wrong. This will be fun, won't it? Okay. Da 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 do do diddle do do. Uh-oh. Uh-oh. Did I actually get it wrong? No, I just left it in the wrong form, didn't I? Can you put this into the right form? And does it match that? Of course it does. Remember, this is M and this is N. And there's the pattern right there. So, guess what? Same darn thing. Woohoo! All right, I really do hope this helps. Give feedback, comments in the stream, and make sure you guys have a great day.